Hi, I'm Mohd from Group M2. Today I want to discuss a little bit about this project. The main objective of this project is to develop material handling system by integrating various sensor and actuation system by using Raspberry Pi microcontroller. And also to determine an operational of material and the system that can be performed through a set of code by using Python language. The main purpose of this project is to design and fabricate the container to store 8 ping pong balls while traveling on the conveyor using recycle box. A few small aluminum plates will added to the container so that the container can be detected by the proximity sensor. The amount of ping pong balls to drop will controlled by the pneumatic cylinder. The two relay used to move the conveyor and also to change the direction of it. Last but not least, the sequence of the whole process is controlled by Raspberry Pi using Python program. That's all.
Okay, my name is Fatullah Haris bin Mazwan. Now I would like to explain the apparatus or the component in this project. Okay, the first one is the container, which is made from the recycle box. Then the conveyor to transport the container. Then over here is the relay to change and move the direction of the conveyor. Okay. Then here is the PLC as a power supply. This is two feeder that contain the ping pong balls, two proximity sensor that to detect the metal on the container. Then we have 4 pneumatic cylinder, which is one is the single acting pneumatic cylinder and another 3 is double acting pneumatic cylinder. Then we have a switch. Then we have a interface circuit, Raspberry Pi, and lastly the monitor.
Hi, I'm Chia Chun Leong. Today I'm going to discuss about the wiring of output components. We have total 6 output components in this project, which is the relay and solenoid valves. The gray wire of all the output components is connected to the PLC output terminal, which is 24 volts, and the black wire is connected to an interface circuit, namely solenoids. The solenoid is connected to the NPN transistor collector, and a base is connected to a GPIO pin, which is set as the output to control the NPN transistors act like a switch. The emitter of the NPN transistors, which is all then connected to a ground, which is represented by this green wire. The green wire is directed to the PLC negative terminals, and also the Raspberry Pi ground is directed to the PLC ground terminal also, in order to form a full circuit. Next, I'm going to discuss about the wiring of input components. We have 3 input components, which is the sensor and the on button. The sensor has 3 wires, which is the brown, blue, and black wires. The brown wire is connected to the PLC output terminal, which is 24 volts, and the blue wire is directly connected to the ground terminal of PLC. The black wire is connected to 2 resistors in series, which is mainly used to drop down the voltage and drop down the current, such as the black wire, which is connected at the center of 2 resistors to the GPIO pin, such as the current supply would not damage the Raspberry Pi. At the end of the resistor in series, the green wire is connected back to the ground terminal. The on button have 2 wires as well. The red wire is connected to the 3.3 volt supply from the Raspberry Pi, and the black wire is connected to a resistor and directly connected to the ground terminal of PLC. Before the resistor, there's a black wire connected from the node to the GPIO port, which acts as an input to read the status of the button, whether it's high or low. And lastly, the ground terminal of Raspberry Pi is also connected back to the PLC ground terminal to form a full circuit.
And now I will talk about the design of our box. And firstly, I will talk about the dimension of the box. This box consists of 3 parts, which is the big box down there, the small box, and a hollow cylinder. The dimension for the below box is 12 times 14 times 8. And this small box will be 2 cm times 3 cm times 6 cm height. And the hollow cylinder will be 4 cm radius and 6 cm height. I will talk about the bottom part first. And as we can see, this box can be opened, and I will demonstrate the opening. And this allows us to take out the ping pong ball more easily. And we can also see that there's a windows at the front which allow us to see the ping pong ball falling into it. And there is also two windows at the side of the box which allowed more light to enter the box, which gave us a better view of the pinball balls. Next, I will talk about the small box. Why we created this small box is because we wanted to place the metal plate, the aluminum plate on it to be more stable, which allow the sensor to sense it better. And next will be the hollow cylinder. This hollow cylinder, we have created a slanting surface on the top to allow the ping pong ball to fall in more easily, to prevent it from stucking at the top. And finally, we have decorated our box with used present wrap to give a better appearance of it. That's it.
Hello everyone, I'm Cheng Teck, and I will be explaining the Python codes. First of all, we import the necessary modules and functions, such as the RPI.GPIO and the sleep function into Python code. Then we assign the GPIO numbers to the respective input and output devices. We set up a count value with its initial value of 0. The count value will play an important part in the following codings. We set up the GPIO for both inputs and output. In this project, the switch, the sensors will be the input, whereas the relays and the valve will be the output. In order for us to put the ping pong balls inside the cylinder, we require the valve to be fully extended first and the conveyor to be stopped. Then, we create infinite loops such as the while loop so that the program can be run infinitely. The first sensor, if GPIO on equal to 1, which means that when we press the green button, a sentence switch is turned on will be printed on the screen. And since initially there are no sensor trigger, so we skip the first condition, the second condition, and we run to this condition, else GPIO output RB1 and RA0. RB1, which means the conveyor will move from the right to the left. And when the storage port is travel from the right to the left, it will trigger the right sensor, so this code will be executed. When the right sensor is triggered, both relay will be 0 and the conveyor stop. A for loop that runs 2 times will be executed by dropping 2 balls into the storage box, and then the count value will be increased by 1. Initially the value is 0 and now it becomes 1. After that, relay B will be 1, causing the conveyor continue move to the left again. And since between the path of left sensor and right sensor, no sensor is triggered. Therefore, we run this code again, else GPIO output RB1. So the conveyor will continue move to the left without any confusion. After it triggers the left sensor, the conveyor will stop. And similarly, a for loop will be executed by dropping another 2 balls into the box, resulting 4 balls in the container now. And the count value will again be increased by 1 to become 2. Since count value is equal to 2, this statement will be run, where RB is 0 and RA is 1. RA is equal to 1, which means that the conveyor will change direction, move from the left to the right. When it moves from left to the right, it will trigger the right sensor again and run the same code again by dropping 2 balls again into a container. Then so far we have collected 6 balls, and count value will be increased by 1 again to become 3. And then the conveyor will move back to the left. When the conveyor moves back to the left, it will, since there's again no more sensor is triggered, this code will be run again. Continue the movement to the left. When it moves to the left and trigger the left sensor, the last 2 balls will be dropped and count value will be added again to become 4. If the count value is equal to 4, RB will become 1 and RA is 0. This indicates that we have finished our program by collecting the total of 8 balls in the container. Therefore, the container has done its job and it will continue move to the left. If the green button is not pressed, or is pressed again, it will return a value of 0 and this code will be run. The relay will become 0 and stop the conveyor, and the valve will be fully extended, and the sentence of switch is turned off will be printed out on the screen. That's all from me. Thank you.